So this presentation is made for two kinds of people, Python developers and R statisticians. The idea is to teach something new to Python developers and to show to R statisticians that they can work in Python too with their tools. So why visualizing data is important? As a human, we clearly see that those four data sets are different. And in fact, this is a quite famous set of data. It's called the Anscombe's quartet, but their summary statistics are totally the same. So a machine could be easily tricked by those four data sets. This is why plotting them is important. We are talking about a grammar of graphics. So a grammar is the set of fundamental principles or rules of an art of science. Why is it important to have a grammar? Because once that you have terms to define concepts, it's easy to think about those concepts. It's easy to discuss about them. So for you, it's much easier to work. The grammar of graphics wants basically to answer the question, what is a graphic, how you can describe it, and how you can create it. The focus is on what you want to display and not how to display it. It's an idea that it's started by Wilkinson in his book, The Grammar of Graphics in 2005, and was implemented by Hadley in the library ggplot2 in 2010. It's an R library. Fortunately for Python developers, there is a porting of ggplot2 that's called Plotnine. And basically, it just take ggplot2 and transfer it to Python with some caveats due to the different syntax of languages, but it's basically the same. It has 2.4 thousand stars on GitHub, so it's quite supported, and it's built on Matplotlib. So a plot is composed by data plus mapping. Data is what we want to visualize, but data alone doesn't say nothing to us because they are just numbers, usually. And a mapping is how to map those numbers to some aesthetic attributes that you can see. In order to do so, the grammar defines those components. So that is that it's called a layered graphics, a layered grammar, because it has components that's just built one on top of each other. So we have scales that maps those data numbers that I talked before to aesthetic components. Coordinates, because as we know, stuff doesn't float in void, but are linked to some scale and coordinate that we define. Facets are a concept where we can divide subsets of the original data in different components, and a theme that basically tells how you will see stuff around. So visualizing those components, we have geometric objects, so the points and the squares that you see on the visualization column, the coordinate system, and the title and background. Altogether, this is a graph. In order to showcase the capabilities of Plotnine, we are going to reproduce a famous graph by Minard that shows how Napoleon invaded very boldly Russia. So this is the soldiers, and the dimension of the line represents the number of soldiers. So in orange, we see the advance into Moscow, and in black, we see the retreat. As we can say, of many that started, a very small amount return back. So in order to do so, we can see that the data contains basically the cities where they go and the number for each, the number of survivors for each position in space. Using Plotnine, for you that know ggplot, you will recognize this syntax. You just define what data you want and you map the aesthetics. until now, this is only the canvas that you're going to use to plot. Now we need some geometric attribute. So those are the aesthetic properties that you will see by eye. A GEOM path, I know this doesn't look very exciting, but we are just connecting the dots present in the data. We need to work a little bit on that. Using the same geometric data, that is the same geometric aesthetics, GEOM path. Now we can map some attributes of the data to some well-defined aesthetics visible on the plot. We have color that shows the direction. So in red, we are going to the right, and in blue, we are going to the left. And the size of the lines is how many soldiers survived. The grouping is needed in order to being able to represent correctly who is who on the graph. Now we just can add the cities that is text that in the grammar logic is just another aesthetic attribute as anything else. And we see that we start having something that looks quite nice and looks quite similar to the original graph. With some more tricks, aesthetic mappings to match the colors and to match the ratio of the original graph, we can see that we obtained a result that is quite similar to the original one, and everything under 10 lines of code. I think, I mean, if somebody wants to try to do the same in Matplotlib, he is welcome to let me know how it went. In this example, we didn't show the concept of faceting. So the original Anscombe's quartet is showcase these capabilities. So we have the data, and it's divided by groups. The group is which one of the 4 combination it is. And we just can say, okay, divide the data using dataset, that is this column that defines the group, on a different window. So in 3 lines of plot, we can explore this dataset in this way. So now I have a question for the public. If somebody wants to give the answer, it would be nice. Who knows the difference between those 2 codes? What will this color do here, and what is the effect of adding color as this aesthetic of jump point here?
Am I allowed to answer?
Yeah, of course.
Please.
So the first one's gonna color everything red, and the second one, you are mapping a color to a variable. So each level of the variable will get a different color.
So which one will have a legend?
The lower one. I mean, maybe both, but the first one will have all red points.
Exactly, this is true, because in the first case, we are using color just not as an attribute linked to the data, but just as an aesthetic attribute because we like red color. And as you can see, everything is red, and we don't have a legend because here the color is not encoding information. It's just a decision that we made. In the second case, as we can see, the color is linked to the dataset, and Plotnine very nicely automatically builds the legend for us, because in this case, color is linked to a concept, a characteristics of the data. And I think that this is the power of the grammar. You don't need to take care about building legends, building axes around and take care of these details. It's all done for you. And in that way, you can explore your datasets quite fast and obtain meaningful results. Thank you for your attention. And those are the references if you want to deep more inside. Thank you.
Thank you, Domagoj.